That is recording now. Cool. So, hello everybody. My name is Seán Kelleher, and I'm a computer science graduate from UCC. I'm currently working at, working with Ignite, working on a tool called RepoGate that I'm kind of developing at the moment. And yeah, I'm just going to talk about phantom types today. Quick introduction. What are phantom types? Essentially is if we have a generic type or polymorphic type in kind of more functional languages, if that type isn't actually used within the body of, shall we say, the class in this instance, or say a kind of algebraic data type, then that type, that generic type is generally said to be a phantom type because it's not actually used anywhere. And that, in essence, is all it is. I'm going to be using Java for the most part today, just to show that even though this is a concept that's generally shown up in kind of functional contexts, that it can actually be applied to more or less any language with generic types. So what is the use of just having this extra type in our type signature? Basically, it gives us more constraints on data. Even though we can have, for instance, if we make multiple instances of this, even though they'd all have the same type of data underlying them, if we give them different types in this empty generic spot, then we can actually constrain those underlying structures. This basically gives us more power because it allows us to reject more incorrect programs. It gives us more kind of flexibility when we're giving signatures to functions. And in a way, we can design our functions so that the phantom types represent essentially runtime data. So you're almost getting access to runtime data at compile time. That enables a few neat features that we'll see in a second. So this is our first example of a phantom type. So again, the concrete value for unit, or kind of the filler value for so this unit type isn't actually used anywhere here to define any attribute. So we only have private double value. The unit value is only used in this static instance, or the static function, where it will actually be populated when the function is called. So what exactly is happening here? So when we define an instance of distance, it'll be given the generic type will be populated at that time, even though the, say, underlying double will always be a double, so it doesn't quite reflect the value that's in the class. We are also able to add that distance with any other distance, regardless of the unit that's inside it. So this is actually a static constructor. So our distance constructor itself is private, so you can't create, well actually you will be able to create a distance with any generic type, but you'll have to do it using this kind of factory, well not factory, yes it's factory method, sorry. Doesn't matter quite so much here, but as we get onto kind of different data types where the validity of the class comes from the constructor, that'll make more sense. But basically what's happening here is this is a class that's designed to overcome the problem that was with, can't remember the exact shuttle launch, but it was basically due to two teams using two different metrics and then merging their code bases without accommodating that.
I think that might be the Mars program.
Yeah, I have the feeling it was to do with Mars, all right, but basically resulted in the rocket exploding, because one team was working with, I suppose, double precision values that represented kilometers perhaps, and then the other team used miles. And so this is going to overcome, this is attempting to overcome this. So I'm going to do a live example with the code I just showed. Here is a main class where we have a distance. So first, I actually don't have any generic types in the distance class, and I'll add them in a second. So what's happening here is in our main, there's a total distance, or sorry, I should probably go through the distance class first. It just stores a distance value. Using this constructor called from double, it'll just simply store the value that it's given. Any distance can be added to any other distance. It simply adds the doubles together, and then you can retrieve the value from the container. And this is used up here. We create a total distance, which is it starts off as 1, and then we have a kilometer defined in terms of kilometers, which is 1, has a value of 1, and then we have a kilometer defined in terms of miles, which is 0. So a kilometer is 0.6214 miles. But because they all have the same underlying data representation, so they're all doubles, they can be added together easily. And the problem here is I've accidentally added the kilometer defined in meters to the total, which is which I'm in my mind defining in terms of kilometers. So that's going to be cause a metrics issue. Basically, what I'm hoping to come out here is 2 kilometers. But as we can see, when I actually run the example, it'll just come out in a second. I've actually gotten 1.6214 because I've accidentally done a typo and removed the k from the m kilometers. So to rectify this, I can add a generic type parameter to the class. And what this is going to allow me to do is give a basically a unit to the distance class. I have my units defined here. You can use you can use interfaces classes or abstract classes, I believe, for this method. I'm just using interfaces because they'll never be instantiated. So I'm going to define my distances in the first guy in terms of kilometers, and the second guy in terms of kilometers because it is, and then I'm going to use miles for the third guy. And now when I try to compile it, you will see that I'll be given an incompatible type error because the distance in terms of miles cannot be converted to the distance in terms of kilometers. So those two values can't be added because even though they have the same underlying type, the phantom types cause an incompatibility. So this, again, even though this is, the values are only computed at runtime, and they have the same runtime representation, but we can get a bit of that information at compile time to prevent compatibility errors at runtime, or sorry, at compile time. So yeah, so that's the first kind of example that I have. And so, as you can see from that, two of the main benefits, as far as I've determined, of phantom types is prohibiting illegal operations at compile time. So I found out that the miles and kilometers couldn't actually be added together, but I also found it out at compile time instead of at runtime. And you can also give different types to same typed data, but allow common operations. So for instance, if I had, say in Java, given used aliases for the two. So if I had used created a new data type called kilometers and a new data type called meters for the integers, it kind of works with integers, but for different data types. If I wanted to then create functions on using those data types, if I created a function for meters, that would generally be incompatible with a function used for kilometers, even though they're both using the same underlying representation. With phantom types, you're able to reuse such functionality. So a second example is in defining a data form. So for instance, if we have a form that we're, for instance, taking from a website, we may have a desire to make sure that any data received from that website has been validated before it's actually rendered in an output page. So for instance, if we receive a PHP or something from a PHP page, say in a post or a GET request, and we then want to render something to the page based on that input, we need to make sure that we validate or sanitize the data so that, for instance, we're not vulnerable to cross-site scripting attacks and things like that. So I'm just going to set this up for our change directories to the forms directory. So what's happening here is that we have, in our main class, we have unvalidated data, and I'm just instantiating the form data. Like, this is all a very kind of maybe uppy example, but imagining that the form data that we're creating from a string has been received from an actual user. We want our render function to only render data once it's actually been validated. So we can see from the start that it's unvalidated, and in fact, this is what I was referring to earlier. By making our constructor private and giving a factory method that only creates unvalidated data, we can make sure that all data has to be validated before it can actually be rendered. So what's going on here? Basically, again, we're just creating a text string that just goes, that's the only attribute of the class. So it's more or less one-to-one correspondence with the actual string. And then we provide one extra method called render, but the only data that render can actually take, or that can actually render, is form data that's already been validated. And we have our interfaces here to define validated and unvalidated data. Problem here is that we're only providing a constructor for unvalidated data, which is what we want, but we have no way of actually converting unvalidated data to validated data. And because the user doesn't have access to our constructors, they don't have the ability to write that. So those methods to actually validate data have to exist within the form data class. So let's try doing that. I'm going to create a...
Sorry to interrupt you, Seán.
Yeah.
Should your class be final? Stop people from subclassing it and creating, if you subclass that class, you'll be able to create validated data.
If the
constructor's private, you effectively.
Yeah. Sorry, so just to actually show you the compilation of what I have so far, you can see again, I'm attempting to render the data, but because the form data unvalidated cannot be converted to validated data, that's basically disallowed again at compile time, even though this is information that we generally wouldn't have till runtime, like you'd represent it using a flag or something in your class to say that it hasn't been validated yet. In this instance, we actually have access to that data at compile time. So going back to this form data, we want to create a validated, we want to validate our form data basically. So we can go create a validated function, and we'll take a form data unvalidated field or data form, and we can return new form data validated, and basically in here now we can define our how we're going to validate our data. Basically, once we put a string in here, that's going to define what a validated piece of or string is. So, for instance, perhaps our system doesn't like text in capital letters, and if we render text with capital letters, again, trivial, but that might cause a problem. So we're going to make sure that all data, once it comes into the system, has to be turned to lowercase. And so we can see that it's still causing an error, so we need to actually add our validated data. So I'm going to call that just data prime. And to validate our data variable, we just use the static method. And so we're going to render data prime instead. And this is actually going to allow it. And as you can see, it's actually been kind of processed with the validation method. And again, if we remove that prime, if we try to render the unvalidated data, unvalidated version of the data, again, it's disallowed. So going back to the point of having values with the same underlying representation and kind of giving common functionality to those. If I want, for instance, there's nothing superficially different between validated data and unvalidated data. They're all just strings, so we would like in general to be able to do general string operations on them. But for instance, say if we want to define an append function, we want to make sure that if we append more data to a form data, then it goes back to being unvalidated again. So I'm going to just give an illustration of that. So if we try to add a string s to our current form, oh yeah, so we can do this. So we can see from this, so all this is doing is basically we can take form data which is either validated or unvalidated, and it doesn't actually matter because again the underlying representation is the same. Yeah.
I always had a question about this, even though I know that this is not the point, but
yeah.
When you use the type T, does it mean like that we'll use a generic type?
So
because everybody uses the type T, including me.
Oh, what's the reason for the letter T or the T in the static?
The letter T.
Oh, the letter T? I'm not sure, just convention, I guess.
It's probably some example.
Yeah, I'm guessing it just stands for the word T. or the word type would be because then they start using T and then S is kind of the next one.
There's
So-
few, yeah,
Oh yeah.
yeah.
Oh, yeah.
If you look up Josh Block's Effective Java, there's an item about the conventions around the names or the letters used for generic types.
Thank you.
No problem. So again, so appending is going to be independent of whether the data is validated or unvalidated, because again, it's just a string at the end of the day, but we want to make sure that if we add some more, say, untrusted data onto our form data, that we make sure that it's unvalidated again. So we're going to check that out up here. So, for instance, if I append some data, for instance, an exclamation mark to my already unvalidated data, then that's fine, because we're going to validate it afterwards anyway. Oops. Method cannot be applied to hidden types. Oh, sorry, I put it in the wrong place. I believe that should be it. Yeah, so it's appended it, and it's validated after the append, but then if we try to do that after we've validated the data, then it's gone back to saying we're appending the data to the validated data type, but we're trying to store it back into a validated data type as well. Which is illegal, so we'll have to store it back into an unvalidated data type or unvalidated variable. So again, so we haven't rendered the data with the extra exclamation mark, so we're going to have to validate our data again to actually get our extra exclamation points. So just to reiterate, so what that's doing basically is we're able to, even though the underlying, so because the underlying data is the same, we want to be able to use a common append method, and we're able to do that even with phantom types, because generally if we had, say, a validated type basically and a distinct unvalidated type, we'd have to rewrite the append method for each. So that is kind of what I wanted to discuss with that one. Also, one last kind of quirk of doing phantom types with Java, because you can't actually dispatch on the type of the generic type, we have to write our functions as static functions. So because so we can't determine at compile time, basically, we're not able to write a method that says if this class is an unvalidated form data, then do this method because this information just isn't there. And so we have, for instances anyway, so we basically have to write it as a static method, even though a lot of the other methods are able to, for instance, render. It doesn't matter what kind of, or sorry, that's a static one as well. In fact, none of these are instance methods. I think the distance one was an instance method. But yeah, a lot of the static stuff we're not able to actually do as instance methods. In fact, the only one we are able to use do as an instance method, which is why I got caught up earlier, is this guy. Because we have kind of this allows for any generic type here, we're able to just remove that and turn it into an instance method instead. So I believe now this should work. Oh, it's
Number of arguments. Yeah. Append as one argument.
oh yeah, and also it returns the new data, I believe. So. Oh yeah, we need to use the actual instance attribute. So yeah, so you can only basically use instance methods when you actually have the kind of generic type. You can't use kind of populated generic type with instances. You have to use static methods. So that is the form data example. So kind of those, again, that was just to kind of give another taste of kind of additional validation you can do at compile time. So this example was to show that, yeah, you can impose kind of data validation constraints on runtime data. The final one I want to look at again is kind of a live example, but it's a lot more involved. It's a bit more advanced, so it kind of incorporates things called piano numbers, or I don't know how you pronounce it, I just call it piano numbers. And it's basically an encoding of numbers in types. Like kind of used a lot in, say, lambda calculus to actually encode numbers as functions and things like that. So I'm just going to open the relevant files here. And the basically how this is going to differ from the example so far is, so the distance example kind of showed you how we can use phantom types to make sure that our underlying data is using the same kind of metrics. Second one was just kind of a Boolean, is my data valid or not? What we're going to do here is going to kind of raise integer values to the type level. So quite similar to what you would do in dependent types, and use that information to actually prohibit you from performing operations such as a head on an empty linked list, or try to do tail on an empty linked list, or those kind of operations which require you to actually have data in your list structure. And so to start off with, I have a linked list class that when you, so it's just, in fact, I need to change directory over here as well. So C. So this is just kind of a standard linked list example. I'm starting off with a nil linked list. I'm populating it, and then I'll print the entire list and get the head of it. So, and then I have this commented out section where I'm creating a new nil linked list, and I'm just getting the head of that. And when I compile that, then I'll get a runtime exception because nil has no head. It's an empty linked list. And down below is the implementation. Very straightforward. We have our private constructor again. Our public constructors are a nil and a const. So you're kind of building up the linked list piece by piece. We've got a standard to string method that recurs down, structurally recurs down the list and prints it, and then a head method which will just throw a null pointer exception if the current list is empty. What we can do so we can actually prevent this null pointer exception from happening at compile time, so we never even need to run the program before knowing that this is going to occur. And the way we do this, or can do this, is with a what I'm calling a sized list here, and what it is adding a phantom type to the linked list structure. So size list is essentially a wrapper around the type. Where are we now? So it has all the same constructors. It has nil and const, and it also has the same head and toString methods. But it also has this phantom type n, which is going to contain an encoding of the natural numbers. So the natural numbers being 0 and every number after 0. So for instance, the successor of 0 is 1, and successor of 0 is 2, and in that way we kind of represent every natural number. But the difference with these natural numbers is that these are actually at the type level as opposed to the value level, so that these can actually be used in type signatures, which is what we're going to do above. So instead of having a linked list here, we're going to have a sized list. And again, it's going to be of integers, but we can also have this type value of 0, meaning that this linked list is going to have size 0. And we're going to instantiate it using the size list nil constructor. And you can already see from the start that that's going to, this is that's a private, or that's within the class, so I have to dereference it. I'll just comment out this exceptioning nil. But you can basically see from the, even before running the example, that this size list is going to, call is going to succeed because the nil constructor just straight off creates a size list of size 0. So now how about we add some elements to it? So so if we want to add an element to an empty sized list, we're going to have to const it. So sized list const, we're going to const it with, in fact, that's just an instance method, and I can const the value 1, for example. But if I try to compile this now, I'm trying to store it back into an empty list type, but it has to be stored in a successor of 0, basically a linked list of size 1. So this has to be, the fact that this list has one element has to be represented in the type. So I'm going to go size 0, or size list successor of 0. So linked list of size 1, and so on for a second element. Now note that because of Java, I'm not really up to date with Java. I'm not sure if it has a method for dynamically determining what type signature you need for a variable, but I know in C# they have just a var that you can use, and it'll infer all that, but we have to create this manually. So this can't be converted to, it's because this guy has to be y1. So this is our list of size 2. We can print that now. And that'll just be the same as, only with one less element. And then we can call our head method safe in the knowledge that there is going to be, can't be applied to, because it's a static method, sorry. Size list and head. But basically, if and when it compiles, we can be safe in the knowledge that at runtime, that isn't going to cause an exception, because if we call it on an empty list, or list of size 0, then that will be caught at compile time. So there is an error. The method in the head cannot be applied to the given types, because it's expecting a sized list which has a length successor of something. So basically it has to be of size at least 1 for you to call this method on it. But the list that we gave it is of size 0, so there's nothing in it to retrieve the head of. Only problem with this approach is that, well, amongst other things, the glaring one is the fact that every time you add a new element to it, you have to redeclare what the actual list is and the data type of that. That can be somewhat mitigated by using, instead of using piano numbers, we can just use, we can say whether the list is empty or inhabited. That allows us to write a main function that is more like this. So once our I'm calling it a populated list. Once our populated list is actually inhabited, we can just add as many elements as we want to that without changing its type signature, because it'll always be inhabited until we remove enough elements for it to be empty again.
You don't actually care about the number of elements in the list, you just care whether it's empty or not.
Yeah, exactly. It just allows us to make the type signature a little more compact. And so that's the benefit there. And so yeah, so then what is the distinction between, like how do these approaches rival dependent types? Because as we've seen there, you can actually approximate values as types using phantom types. And for those of you familiar or unfamiliar with dependent types essentially allows us to use values at the type level to do similar things. So we can say in our computations that if we have, for instance, a list of length 2 and a list of length 3, and we add them together, then we get a list of length 5. And we're able to do these things because values actually exist directly at the type level. The difference with phantom types is that we're actually enumerating, like we're basically simulating those values at the type level. So they're not using actual values at the type level, they're only being approximated using these piano numbers. Whereas with dependent types, you're actually using the values directly. So you don't have to, for instance, with phantom types, we would have to create, for instance, the integer value, and we'd have to create the integer type value. Whereas in dependent types, we just define the value integer in one place, and then we can use those in our types. So that would be a big distinction between the two of those. And yeah, just as a recap, the main benefits of phantom types, in my opinion, would be the fact that we can get runtime data at compile time, and then use that to reject some programs that we normally wouldn't be able to. And we can also, this is second benefit isn't as compelling in my opinion, but it's just because it doesn't, I feel, come up in practice so much, but allows us to give common operations to same types of data with different phantom types, basically. And yeah, so these are some of the example uses I went through. One thing I didn't do was, another example is if we open a file for reading, we can make sure that if we ever call a function on that, it'll only be a read function, for instance. We can't call a write method on a file that's been opened for reading, and we can assert that at compile time, as opposed to finding out later when we run the program that, oh, you tried to write to a file that was only opened for reading, for instance. And again, that would just be using the same, would be very similar to, say, the validated form data example. So yeah, that's about all I researched into phantom types anyway. Yeah, any questions? That's okay too.
Yeah, it's like kind of the validation and XSS.
Yeah, it's class. So I guess you're kind of forced to use static methods, right? Because you can't modify the behavior. You can't write different. You can't vary the implementation based on the
Yeah,
phantom
exactly.
type.
No.
Yeah, there's no dispatch for that.
They're the two different types would have the compiled out the same type. The type is arranged, so
You might get away with it in C# because you don't have type erasure, but I don't.
Yeah, that makes sense.
you know, in Scala.
Well, you have type erasure in Scala. But
You do. But
Yeah.
It's a compiled out problem though. It's not strictly speaking necessary just because it's type eraser. It's just the way Java is implemented. Pretty close correspondence.
No, but what I'm saying is, you might want to have methods on, form data validated that you wouldn't have on form data invalidated, that kind of stuff. That's what I mean.
Yeah, in that case you would.
It's getting more complicated.
But if you define a static method that you can say, well, only apply this method to form data, like you did, exactly.
Yeah.
So I'll just shut up now.
Yeah, so basically you can't dispatch on kind of the generic type, I assume, because of type erasure, so you do have to work around it.
Yeah, it's basically that. It just puts it down to a method that takes the raw objects.
Yeah.
Two of those.
And I suppose if you look at kind of Haskell examples, which is what threw me at first, it looks like that isn't an issue, except then I realized, well, all functions in Haskell are static anyway because they're they're common to all. They're basically global static methods. So it actually is kind of a similar problem, not a similar problem, but it was just closer than I thought. Sorry, did you have a question?
I have liked the presentation, but I was a little bit disappointed when I arrived and seen that you were presenting the thing in Java and not in OKML, Haskell, KML.
Next-
Would be-
Actually, what we can do is we can do a cat on it next time. And everybody can do
Yeah.
something with phantom types in their own. What's your preferred language?
At the moment, OKML, and so you can invent types, and I would totally see this, and I'm sure that you know it,
Yeah.
or maybe Haskell because this is very close.
It is a lot smoother looking in those languages, and if you most of the examples I would have found on the web anyway would have been in these functional languages, just because I felt it'd be more interesting to do it in Java, just because even though it's talked about, I suppose a lot more in functional paradigms, it isn't intrinsically attached to functional language. So just to show that these ideas can be applied in just general programming languages, same as when you think of, for me anyway, when I think of say higher order functions and functions taking functions as values and things like that, I tend to think, functional programming, even though that's prevalent in C and Java and in the form of passing classes around and things like that, just to show that, and particularly because all you need for phantom types is generics, I thought it'd be interesting just to see it from that point of view.
Yeah, I kind of like the way it was in Java actually, because when I go back to Java after using the functional programming language with algebraic data types, you kind of really miss some Could this be almost a way to do what you could do with algebraic data types in say Scala or Haskell? I wouldn't replace them or anything, but
I wouldn't say with algebraic data types, but just those principles of phantom types anyway are
But it's just making impossible states impossible. You can kind of do that.
Oh, yeah, it's another tool than that.
Yeah.
I suppose that's more about structuring your data nearly than type of I even with one of the examples, I think. Yeah, in fact, for the lists example, I had like that's my linked list implementation. But like for instance, when this linked list represent is used for the nil constructor and the the const constructor, and basically when it's nil, those two fields just go to waste, and it's kind of I'm just using the kind of public-facing constructors to constrain, like kind of wrangle my way around those. The fact that the type system doesn't have algebraic data types, and kind of try and impose those constraints on the programmer.
So if you were using like Scala or F# or Haskell or something, and you were trying to make impossible states impossible, would you be more gearing towards this method of phantom types, or would you be more using algebraic data types? It kind of depends, I suppose.
Like if I was actually using a functional.
Yeah.
I just use algebraic data types, just because otherwise you do have this kind of data in your constructor or in your class that just isn't used, basically. And even stuff like I use Go a lot now, most of the time these days. And again, like I was creating a kind of JSON parser for a while, like kind of a schemaless JSON parser, so it would just parse data type or parse some data and store it in a structure. But it was kind of a messy algebraic data type, because you just have this kind of JSON item type, which can then contain other JSON item types, but you also have to kind of tag it with what kind of type of thing is in it as well, and you have to have a field for, say, JSON string, JSON integer, JSON X, Y, and Z, even though only one of those is going to be populated based on what the actual tag on it is. But yeah, unless you either have algebraic data types or you don't, I suppose. There are ways to kind of make it feel more like you do, but yeah, there's no replacing.
My question is just a more general Java question. It goes back to, remember you said that you have the private constructor, but you still have the automatically generated public constructor with the default, wouldn't you?
Not if you override.
If you define your own constructor,
Yeah.
then you don't get the default.
You don't have the default one. Okay.
Yeah. Just first of all, congratulations for your talk. It was very, very well presented. Just wondering, what are the trade-offs about using front-end data types or actually creating real types in some situations? Because we are only using the front-end data type as a label for our objects.
Yeah.
Wouldn't we, in some situations, be better off creating the real type for that? Like the second example that you gave, where you have the data and then the valid data.
Yeah.
You could create a class valid data, which is a decorator from the other one, and then we just instantiate the valid data from the data, and then, you know what I mean?
Yeah, exactly.
But of course, if you start repeating this pattern over and over again, then you can
Yeah.
have labels and then use phantom types for that.
Yeah, that's the thing. Like from what I've gathered, it does seem to be more like if in those extreme circumstances, you wanted to do, like if you're doing something like that, like then phantom types would make a lot of sense. In general, I feel like they're solving a problem that I don't necessarily have a lot of the time. One reason you might want to use it, even if you just had the two validated and unvalidated, is the fact that, again, you would have, say, if you had a lot of operations that were common to the two, but you'd have to, redefine them in both places, because you'd have to define them on, this is how you concatenate unvalidated data, and this is how you validate, or concatenate validated data. And you might not necessarily want to define it in both places.
Yeah, or if you want to have this pattern of valid and invalid particular data, so let's say you have loads of entities in your system, and for all of those entities you want to have them valid and invalid, so you won't be duplicating all the classes you have. The valid version of it, so you could label them with the generic type.
Yeah. And again with like trade-offs and stuff, like you know, you are like I have read on say some Quora. Yeah, I have references here as well actually, and anyone can email me for the slides. But kind of there's like a Quora question where he's asking what are the benefits and drawbacks of phantom types, and one of the drawbacks, and it, as it seems to me as well, is just the fact that you are kind of complicating your type signatures with these phantom types, because it's not necessarily natural, the fact that you have a type there, but it doesn't actually, it's not the type of anything in your class. It's just there, like it's kind of extra data, so it can kind of muddy your types a bit, and especially in the case of say, like I feel like piano numbers, while a neat theoretical thing, are just like completely infeasible to use with your production. Yeah, especially with Java. Maybe with like C# where you can just hide this with your dynamics, but not quite, doesn't quite scale.
Yeah.
I would argue though that, I mean, if you sparingly, like, I suppose one use case I would definitely see for phantom types would be ID types. So let's say you get different types of accounts in your system, and you don't want to mix them accidentally, so you'd have ID of, and then you'd have phantom types for enterprise account, or that kind of stuff. Yeah. And it would be like very for documentation it would be great, and it would it's very similar to what you described with units, but just applied to ID types in your system.
Yeah. It is particularly useful for those cases where you'd even just have a flag in your class that says this object is of this type and it should only work with other objects of this type, or
you bring it to the type level with phantom types.
Exactly, and by doing that you just are catching it at compile time instead of runtime. And yeah, you're only once you add in kind of type families and stuff, you're just a stone's throw away from like dependent types and stuff like that. But yeah, it gets very complicated then. But yeah,
maybe next talk on type families.
Maybe if I understand.
That'd be good.
I want to ask this question since I am with other people going for functional programming, maybe, at least you. Have you guys used it for real projects?
Functional programming?
Like real side projects, yeah.
Like OKML, Haskell, things like this?
Yeah, a small bit.
We use Scala usually where we work. Yeah, for a few work there. So.
And since there are some programs to transform your code in C, this is as efficient as the C or the Java, right?
Well, for me anyway, I wouldn't have done them to any scale that performance would even be an issue for me, really.
Okay.
So I couldn't. So.
No, I don't know if you can make blanket statements, but there are examples of solutions that are quite readable in Haskell that are actually faster than C implementation, pretty much the best C implementation you can come up with.
Because this is very natural to implement the things. So I was wondering if on Shine's side it was working.
I think it does. There is the example of the sort Haskell. That's the concrete example.
But it's a bit of a cop-out.
We won't talk about that.
Yeah, no.
Well, it's not actually quicksort.
Well, it's not for. Well, yeah, it's not quicksort.
It looks very readable, but it's not quite what it's advertised. advertised as.
Yeah, and then like the actual quicksort implementation is like way bigger than the C version of the same thing, and yeah, quite a bit slower, I believe.
Okay, well, round of
Thank you
applause.
very much.